Hello all. I shall just brief you on the isolation of terpenoids under the heading Isolation of Natural Products. Now, as you know, terpenoids are obtained from plants, and there are complex terpenoids and simple terpenoids, and each plant will be having different types of terpenoids in it, and different plant parts will be having different types of terpenoids and different quantities of the same terpenoid. So the first thing when you isolate a natural product is to identify the correct exact plant and also the exact plant part from which we will get good yield of a particular terpenoid. So understanding the phytochemicals or the understanding the biochemistry of plant is very important to extract essential oils, terpenoids, or natural products in that case to get a good yield of the same. Now, most of the terpenoids are steam volatile. Most of the particularly simple terpenoids are steam volatile, and the terpenoids are present in essential oils. So first, in order to get terpenoids, first what we have to do is extract the essential oil and then isolate the terpenoids from the essential oil extracted. So first we have to isolate the essential oil from the plants and then separate the terpenoids from the essential oils. So let's discuss each step in detail. Let's take up the first one, that is the isolation of essential oils. How can we do that? Essential oils can be isolated from plant parts by these four methods: expression method, steam distillation method, solvent extraction method, and enfleurage or adsorption in purified fats. Now let's take each method individually. Let's take the expression method. Expression method is also called as cold pressing. Now here what we do is we crush the plant part, whichever plant part has got the particular terpenoid, and then we make it into a juice. Okay, and then remember, do not crush it very hard because sometimes they may get degraded, the compounds. So crush it properly and then filter the juice, remove the residue, then centrifuge the juice. You get a centrifugate which will be having the essential oil in good quality. Okay, and the residue of after centrifuging, the residue which you get is subjected to steam distillation later to extract the remaining essential oil. Now the essential oil which you get from the residue after steam distillation of the residue will be of inferior quality. So you get two grades of essential oil from this: good quality, superior quality essential oil, and the inferior quality essential oil. Now this particular method is used particularly to extract heat sensitive essential oils, because here you are not supplying any heat. This is also called as cold pressing. So citrus terpenoids like limonene, etc. can be extracted, or citrus essential oils can be extracted by this method. Now next method, that is distillation. We usually go for hydrodistillation, that is distillation using either water or steam. So here what we do is we take the plant material and subject it to water distillation. You immerse it in water and then heat it, or you pass steam to it and then extract it. So we have got different types of hydrodistillation. One is water distillation, then we have got water and steam distillation, and then we have got direct steam distillation. Now here, let us first discuss water distillation. The apparatus or the setup for water distillation is like this. You have got a heating mantle here. This is the RB flask in which you take the plant material. This is the adapter. This is the condenser. And this is the collector conical flask in which you collect the distillate. Alright, so this is the simplest way of setting up the apparatus for water distillation. Now in water distillation, what we do is the plant material is completely immersed in water in the RB flask, and this is boiled using the heating mantle. Okay, now so here there is direct contact between the boiling water and the plant material in water distillation. Because the plant material is in the boiling water, there is direct contact of the plant material and the boiling water. So the disadvantage of this, so what happens is when you boil the plant material along with the water, steam will be produced from the water, and the steam volatile essential oils will come out along with the steam, and that will be passing through the condenser, and then it will be collected in the distillate will be collected in this conical flask. So that's a simple procedure, simple way of collecting the essential oil. Now the main disadvantage of water distillation is that complete extraction is not possible. Okay, and also certain esters which are heat sensitive will be hydrolyzed, and certain aldehydes present in the essential oil will be polymerized. So that is a bit a disadvantage of over here. And also heat sensitive, we cannot get heat sensitive terpenoids by this method. So water distillation is used for in those cases in which we cannot extract the essential oil by water and steam distillation or by direct steam distillation. Alright, now coming to the next method, that is water and steam distillation, and also direct steam distillation. The setup is something similar in both the cases. Now let us take up the first one, that is water and steam distillation. Now in water and steam distillation, what we do is we first take the plant material and then immerse it in water for some time. Alright, you call it as maceration. Okay, you immerse it in water for some time, and then after that you supply steam from a satellite boiler. Okay, this is called a satellite boiler, that is a steam which is produced outside the still. This is called the RB flask. Steam is not produced inside the RB flask, it is produced outside. So the steam is generated, from the steam generator, and it is passed into the round bottom flask having the plant material and water, and from there the steam volatile essential oils come out through this condenser, and it is collected here. The distillate is collected. Now here we can either send the steam from a satellite boiler, or if you are heating the still or the RB flask directly, make sure that the plant material does not come in contact with the boiling water. So the plant material is placed above the water in a grid, perforated grid. That is what is done. So here the plant material and the boiling water does not come in contact with each other. The same case is for direct steam distillation also. Now we get higher yield in this method, and components of the volatile oil are less susceptible to hydrolysis and polymerization, because we can control the heat by, since the material is not coming in contact with the water, it is placed above the boiling water in a perforated grid. Now the steam and water distillation is faster than the water distillation method. But there are a few disadvantages for this method. Due to the low pressure of a rising steam, oils of high boiling range require a greater quantity of steam, so longer hours of distillation will be required. And since the plant material, we are macerating the plant material, the plant material becomes wet, and that will slow down the distillation. Now that's another disadvantage. And also when you are placing the plant material on the grid, that also takes some, the grid becomes waterlogged. Lower part of the grid becomes waterlogged, and that also will lead to the boiling of the plant material. So the plant material and water may come in contact, so that may lead to this decomposition or hydrolysis of the essential oils. Now, coming to the direct steam distillation, the method is almost the same. Remember, you don't immerse the plant material in water. We take the plant material either in the dry form or as such. So you don't immerse the plant material in water and then pass steam directly to the plant material. You don't boil it here. This burner will not be there in direct steam distillation. You'll be passing the steam from a satellite steam generator, and it is the steam is passed into the plant material in the still or the RB flask, and then the steam, volatile essential oil, will be passed through the condenser and will be collected here. Now, if you're not using a satellite generator, what you do is, the way you have done for water and steam distillation, take the plant material in a perforated grid and place it above the boiling water. Okay, if you don't have a satellite steam generator. The advantage of satellite steam generation is that the amount of steam can be readily controlled by us, because steam is generated in a satellite boiler, and we can keep it, remove it or place it for more time according to our choice. And also the plant material is not heated above 100 degrees centigrade, and so thermal degradation can be avoided to the maximum. This method is the most acceptable method, that is direct steam distillation is the most acceptable distillation method. The disadvantage of steam distillation is only that we need to maintain an external boiler, steam generator. The rest of the apparatus remains similar to the simple distillation method. So these are the three types of hydro distillation. So if we just brief what we have discussed, the water distillation method is most applicable to such plant materials which is dried initially in air and the constituents are not degraded by boiling even up to 100 degrees centigrade. Turpentine oil is an example which can be extracted by this method. The essential oil from turpentine oil can be extracted by water distillation. Now, in the water and steam distillation method is suitable for plant material which are either fresh or dried, and the constituents of which undergo degradation by direct boiling. So for such materials, we go for water and steam distillation. Clove oil, cinnamon oil can be extracted by water and steam distillation. And the direct steam distillation method is applicable to fresh plant material that is loaded with sufficient natural moisture. We need not macerate it. That is, we need not immerse it in water before distillation. Peppermint oil and spearmint oil are examples which can be extracted by direct steam distillation. Now coming to the next method, that is solvent extraction. Now in solvent extraction, this is carried out particularly to extract heat sensitive essential oils. So essential oils which cannot be extracted by distillation because they get degraded. So such essential oils are extracted by solvent extraction methods. So what we do is we immerse the plant material in solvents like petroleum ether, methanol, ethanol or hexane. Okay, and then immerse it for some time. We will not heat it, and then the essential oils will get will go into the solvents, and we can remove it. We'll filter off the plant material from this solvent, and then we'll subject this. We'll boil off the solvent by under reduced pressure. We won't heat it. Under reduced pressure, and then we get the essential oil. Now here the thing which you must understand here is that the solvents which we take here are volatile solvents. So we extract the essential oil in volatile solvent. So we go for plant materials which are very delicate, or for when we need to extract heat sensitive essential oils, we go for this method. The method is very simple, but the problem is that we require high amount of solvent over here. A lot of solvent is required, and that is against the green norms which we follow now. So instead of the solvents, the volatile solvents which we use, nowadays we can go for supercritical carbon dioxide, which will dissolve the essential oils in it. So here when you are using supercritical carbon dioxide, we are not using volatile solvents, and we are going in the green way. And the problem is when you use supercritical carbon dioxide, it is a bit more expensive. No other problem with this. The rest is this is a very good method. And when you're using solvent, some people do not agree of using that essential oil for aromatherapy because there will be some amount of solvent in it. But if you're using supercritical carbon dioxide to extract the essential oils, then we can use it for aromatherapy also without any hesitation. So that is about the solvent extraction method. Next is the enfleurage or essential oil extraction with cold fat, that is by adsorption, and a process of adsorption happens. Now what we do here is you take a container or a flat base and on which you spread the fat. Okay, you spread the fat and heat it to up to 50 degrees centigrade. Okay, and on this hot fat, you place the plant material, particularly what you do is the plant petals, flower petals. So rose petals, jasmine flowers, etc. can be are placed on this, and then keep it as such for 24 hours. Then the essential oils, all the fat soluble essential oils, will ooze out of the plant material into the fat. After 24 hours, remove the petal, place fresh petals on the fat, and continue this process. Okay, replacing the fresh plant material with replacing the older plant material with fresh plant, you do every 24 hours, and at the end the fat gets saturated with essential oil. That saturated fat is taken and then it is digested with ethanol, that is, you treat it with ethanol. And when you do that, the essential oils will come out into the ethanol and the fat will be separated. So fat can be separated. So whatever small amount of fat has been come out along with the ethanol can be separated again by cooling it. Okay, this fat and ethanol will be separated, and the essential oil will be present in the ethanol. And then ethanol is removed under reduced pressure. Here again, you don't heat it. The ethanol is removed under reduced pressure, and you get the essential oil over there. Alright, so these are the 4 methods of extraction of or isolation of essential oil from plant materials. Now, instead of fat, nowadays coconut charcoal is also used to extract for this adsorption method, enfurage, because here the adsorption capacity of coconut charcoal is more than fat, and the procedures are much more simpler over here when you use coconut charcoal. So probably maybe you can try other charcoals also and optimize whichever is good. You can go for other bioadsorbents and see which is good for extraction of essential oils. Alright, so these are the 4 methods. Now coming to the separation of terpenoids from essential oils. That's the next step in order to get the terpenoids. Now we can separate terpenoids from essential oils by 2 methods, that is either by chemical method or by physical method. Let's go for the chemical methods. There are different types of chemical methods based on the type of terpenoid which you are extracting from the essential oil. The first one is for separation of terpene hydrocarbons, that is terpenes which do not have any, which has only carbon and hydrogen in it, like terpenoids like limonene and humulene. This 6-membered ring structure, this is limonene, this is humulene. See, there are no other atoms other than carbon and hydrogen. Now what we do here is you take the essential oil and then treat it with NaCl and CHCl3. Okay, so you get an adduct, nitrosyl chloride, and essentially the crystalline adduct, the essential oil, the terpenoid will form an adduct, and you get the crystalline adduct there because there are unsaturations here, and it will be forming an adduct. And then that crystalline adduct is separated and then decomposed to get the terpene hydrocarbon. So that's one method of separation of terpenes from essential oil. That particularly you can remove or separate terpene hydrocarbons, that is terpenoids which do not have any other atoms other than carbon and hydrogen. Now, the next method is separation of alcoholic terpenes. So if you have alcoholic terpenes in essential oils, what you can do is like terpenoids like menthol, thymol. This is menthol, this hexanol structure, and thymol. Such terpenoids which has got oxygen in it, alcoholic group in it. For that, you take the essential oil and treat it with acetic anhydride. Esters will be formed, diesters will be formed, and here the diesters will be formed for if you have primary and secondary alcohol only. Tertiary alcohols will not form diesters, so you cannot separate essential oil having tertiary alcohol by this method. So once the diesters are formed, it is extracted with sodium bicarbonate. After treating with sodium bicarbonate, it is treated with alkali, and you get the alcoholic terpenes. So these are the steps used to remove or to separate alcoholic terpenes from essential oils. Now, third one, that is separation of ketonic and aldehydic terpenes like camphor and abietic acid. There is a double bond over here. Camphor. Here carboxyl group is there. There is another, again a carbonyl group here. So the carbonyl group in terpenoids containing carbonyl groups can be separated by this method. How do we do that? Take the essential oil, treat it with either sodium bisulfite, or sodium bisulfite or phenyl hydrazine or 2,4-dinitrophenyl hydrazine or semicarbazine. You get the corresponding adduct. The hydrozones all sulfites are obtained. The corresponding adduct is obtained. This adduct is then separated and decomposed to get the terpene hydrocarbon. Sorry, not terpene hydrocarbon, there's a mistake here. The ketonic and aldehydic terpenes. Okay, not terpene hydrocarbon. So these are the methods by which you can separate different types of terpenes. So if you have all these terpenes, these types of terpenes in your essential oil, you can go for any of these methods. Or all these methods, one by one you can go. First you can separate the terpene hydrocarbon, then you can separate the alcoholic terpenes, and then you can go for the separation of ketonic and aldehydic terpenes or terpenes containing carbonyl group. Essential oil, we can adopt any of these chemical methods. Coming to the physical methods, we have basically we go for two methods, that is fractional distillation and chromatographic method. In chromatographic method, we can go for adsorption chromatography like column chromatography. We can go for partition chromatography. We can go for vapor phase chromatography. We can go for gas chromatography. Any of these methods can be adopted. Gas chromatography will give us the terpenes in its purest form. Alright, so these are the various chromatographic methods which can be adopted for separation of essential oils from, separation of terpenoids from the essential oils. Now coming to the fractional distillation method, this is the experimental setup for fractional distillation. I got this picture from, I've borrowed this picture from somebody else. Now you take the essential oil, this RB flask, connect the RB flask to fractionating column, connect it to an adapter, the adapter is then connected to the condenser, and then it is collected, the material will be collected in the receiving flask. Okay, the distillate will be collected in the receiving flask. So here what happens is, when you heat this essential oil, remember you need not supply a lot of heat, mild heating is enough. The terpenes which are having a low boiling point will boil first, will be collected first in the distillate. Then after some gently increase the heat, and the next boiling terpenoid will be collected, and so on. So you get different fractions of terpenes. So here first the terpene which comes out first will be terpene hydrocarbons, which are the lowest boiling terpenes. Then oxygenated terpenes like alcoholic terpenoids will come, and then followed by your aldehydic and ketonic terpenoids. Then whatever was left after fractional distillation, the distillation of the residue, this residue which will be left after distillation will be distilled under reduced pressure. Then we get the sesquiu terpenoids, that is higher terpenoids will be obtained. So these are this is a way by which we separate the terpenoids from the essential oil by fractional distillation. So we have discussed the isolation of essential oils from plant material and then separation of terpenoids from the essential oils in brief. Okay, both the chemical methods and physical methods. Hope these are clear to you. This is just a brief explanation. If you just go through books related to natural products, you will get more informations in detailed information regarding all these methods. Thank you.